Hi everyone. If you are watching this video, you are probably looking for a little bit of clarification on how to complete the process for an addition polymer. Perhaps you missed class earlier this week and this is the first time you're seeing this. Maybe you were in class and you're just kind of looking for a bit of a refresher. I'm going to do a couple of the questions from the workbook. This is number 10. It's on page 10 in your workbook. I did do this example in class, but I'll go through it again for the benefit of anybody who didn't see this in class just a few days ago. All right, so I'm going to draw my polymer just slightly different. This is going to be the addition polymer for polypropylene. We're going to use the monomer propene, which is already drawn out here, but like I said, I'm going to draw it a little bit different. I'm going to draw the CH3, the first CH3, sort of in a downward position. It's still the same molecule. It's still 3 carbons in a row with 1 double bond. I'm just kind of focusing on the double bond and not what's attached to the carbons on either side. So to kind of move everything out of the way and focus only on the double bond, I'm going to draw that methyl, that CH3 group, in a downward position. Now, every addition polymer starts with the same step 1 initiation. And when you're doing your quiz and on your exam, this is typically what we want to see through your question. So, step 1, initiation. You need to create what's known as a free radical. A free radical is a highly energetic single electron, an atom that has a single electron. It's very reactive, and it will try to add to our monomer, to our double bond specifically, in order to create another free radical, but a free radical of the monomer itself, and not just atom X or oxygen or hydrogen or whatever we start with. We always start with a diatomic compound. In your notes online, it says oxygen, O2. It's not necessary that it's oxygen, so I always use X2 just to represent any diatomic molecule. Could be nitrogen, oxygen, hydrogen, chlorine, fluorine, bromine, iodine, anything that's an 2, an O2, an X2, an X2, okay? This X2 gets exposed to high energy ultraviolet light and essentially cracks the bond between the 2 X atoms, whatever they are. And it creates 2 atoms that contain a single electron. That's the dot you see here next to the X. So 2 X free radicals, 2 X dot. Step 1 for all your step 1 for all your addition polymers will be exactly like this. This is step 1 right here, initiation phase. Step 2 is propagation. I'm not sure where that 11 just popped in there from. Weird. Our propagation phase, this is where we're going to add the monomer to itself and sort of replicate the compound in order to create a polymer, many monomers together. We typically ask for 3 propagations, so 3 additions of the monomer. We start off with our X free radical. It gets thrown into the mix with our propene, with our monomer. And again, notice I'm going to draw this monomer slightly different than what's in the question. I'm going to draw the CH3 in a downward position to kind of keep it out of the way. Our X free electron, being very highly reactive, tries to bond to the carbon, the first carbon of the double bond. It'll come in and try to make a bond with carbon. We use curved half arrows to represent the movement of an electron. So X comes in, tries to bond with that carbon. That carbon now has too many bonds on it. It originally had 4, which is good, it's fine. But when X tries to bond, that makes it 5. Carbon becomes unhappy, and the double bond will break to make room for the incoming X atom. When that double bond breaks, it turns into a single. Okay, so in that double bond, there's 4 electrons. Right? Remember that a double bond is 4. One of the 4 electrons comes to the left to meet the incoming X dot, X free radical. The second of the 4 electrons moves to the end of the chain, and the third and fourth of the 4 electrons remains as a single bond. So what we end up with is X that attaches now to my monomer. My double bond has become a single. There's my CH3 group still in the downward position, and my free radical electron moves to the end of the chain. Now, in this particular process, the only thing present is the monomer itself, so it has no other choice but to add another molecule of itself. There's nothing else in the mix. The only thing present is the propene monomer. So that new free radical that's generated, that monomer that now has that single unbonded electron, again, very highly reactive, free radical electron comes in, tries to bond to that carbon of the double bond, creates too many bonds for that carbon, forces the double bond to break. One electron goes left to meet the incoming, the other goes to the right along the end of the chain, and the double turns into a single bond. So I'm going to move down to the next line here to draw my molecule. So X, CH, CH2, there's my CH3. It's bonded to a CH that has a CH3 in the downward position, and that double has now become a single, and my free electron is at the end of the molecule. So you can see here there are 2 repeating units, 2 monomers added, and 2 repeating units. Now we typically like to see 3 in our propagation phase. So I'm going to add a third. The only thing that's present again is the propene monomer. So that's a 3. And the process is going to continue like this until eventually we get to a point where we're going to stop it. So single electron comes in, tries to bond with carbon, forces the double bond to break. One electron comes left to meet the incoming electron. One electron goes right to the end of the chain, and we get another free radical formed. So bear with me for a second while I draw. When I draw this, I'm going to try to do it a little bit smaller so I can fit everything on the page. This time you can see there are 3 repeating units, and don't forget your single electron on the end. Just in case anybody can't see, I'll show you where they are. So the 3 units are going to look right like this. There's 1, there's 2, right, and there's the third. Okay, so 3 units. That's usually what we ask for when we ask for this type of question, to show 3 repeating units. So after you have your 3 units, we'll say our propagation phase is finished. We're going to go into step 3. Step 3 is termination. In termination, we're going to add a molecule of hydrogen, a compound of hydrogen, H2, in order to stop our process. So termination, I'm going to say add H2. And if you want to show H2 as H-H to represent the two hydrogen atoms and a single bond between them, that's fine. I'm going to redraw this third propagation product again because I want to show it on a separate line here so that it's a little bit bigger and a little bit easier to see. So there's my 3 repeating units, my single electron on the end. And don't forget your downward methyl CH3 groups. CH3 is called a methyl. Okay. In the termination phase, a stream of hydrogen gas is bubbled through the reaction vessel so that our single electron here will react with the hydrogen, H2. It's going to do the same thing. That single electron will do the same thing as it did in every other step. The single electron tries to bond with hydrogen, creates one too many bonds for hydrogen. That single bond between the two hydrogens breaks. One electron goes left to meet that incoming. The other electron goes right to join to, or just to stay with that hydrogen. And what we have for our final product looks like this. So I'm going to redraw this structure again. It can get a little bit tedious and a little bit lengthy depending on what the monomer is. Okay, so I left off that 2 purposely right now just for 1 minute. Okay, so here's my monomer, or sorry, my polymer chain. This CH2 single electron here, when that part of the polymer tried to bond with hydrogen, that CH2 adds a third hydrogen. So on the end of our chain, that CH2 is now a CH3, but everything else through the polymer chain has stayed the same. As you can see, it's still 3 repeating units, haven't changed anything else. The other hydrogen, the other part of the H2, becomes a free radical and is free to go off now and start the entire process again with a new monomer, or perhaps even end a chain of another one. Just depends on the process of what's happening here. This particular question and all of this here, this is typically what we like to see in terms of a question on your quiz or on your final exam. Now I will say that your quiz and your final this year are multiple choice, so I'm not 100% sure how we're going to test this particular question yet, but I'm pretty sure you're going to have to write this process out on your scrap paper and then answer multiple choice questions about your workings, and hopefully your workings are correct and they'll match the choices in the multiple choice question. That's sort of what I'm figuring. All right, so that one is the process for propene to make polypropylene. I will do a second video just on another monomer in another video to make it not so long. All right, so try this process yourself. See if you can replicate what we have here. And it definitely is, the more you practice with it, the easier it gets. So give it a try and see if you're able to replicate this polymer process for the formation of polypropylene. Good luck.